Hello, sir. We'll be starting just in a bit. We are just waiting for some of the students to join on our YouTube live link. So we are live on YouTube, sir. I think we can start the session now. So good afternoon, everyone, and a very warm welcome to all the distinguished guests, eminent speakers, educators, and most importantly, the young participants of the National Automobile Olympiad. It is my pleasure to welcome you all to this special industry session on Introduction to Automobile Design. The National Automobile Olympiad, an initiative of the Automotive Skills Development Council in collaboration with CBSE, aims to provide students with an opportunity to explore the fascinating world of automobiles, emerging technologies, innovation, mobility, and the diverse career opportunities that the automotive industry has to offer. Today's session brings together distinguished representatives from CBSE and the automotive and design ecosystem, who will provide our young participants with a comprehensive perspective on automobile design from its history and evolution to understanding its fundamentals and finally exploring its growing importance and the exciting career opportunities it presents. We are honored to have with us Shri Satish Pahal, Joint Director, Department of Skill Education, CBSE Delhi, as our distinguished guest. Shri Satish Pahal is currently associated with CBSE and is looking after various projects related to skill education and digital transformation. He has previously served in the Ministry of Social Justice and Empowerment and the National Council for Teacher Education under the Ministry of Education in various capacities. An engineer by education, an academician by profession, Sri Satish Pahal is a scholar in the field of computer science and has a keen interest in technical teacher and school education. Alongside him, we are privileged to have three eminent personalities from the automobile and design world with us today. Sri Gautam Sen, celebrated automotive journalist, author, and historian. Sri John Paul Oyono, celebrated industrial designer, former designer associated with BMW and Zagato. And Sri Ivy Rao, distinguished fellow of TERI and former managing executive officer R&D with Maruti Suzuki India Limited. We are truly delighted to have all of you with us today, and I'm sure this will be an enriching and inspiring session for our young automobile enthusiasts. So with that, let's begin today's session. To begin today's session, I would now like to invite Shri Satish Pahal, Joint Director, Department of Skill Education, CBSE, to address the participants, share his thoughts on the importance of skill-based learning industry exposure, and initiatives such as the National Automobile Olympiad in preparing students for the future. Sir, may I request you to kindly address the participants? Over to you, sir.
Thank you so much, Neha. Good afternoon, respected dignitaries, representatives from ASDC, our industry partners, eminent experts, teachers, and students. It's a pleasure to join you all in this exclusive session on Introduction to Automobile Design. I would like to congratulate ASDC and all partner organizations for organizing this insightful initiative under the National Automotive Olympiad 2026. You know, at present, automotive industry is witnessing so much transformation with the with the introduction of electrical mobility, connected vehicles, AI, use of AI, and sustainable technologies. These kind of developments demand a new generation of skilled professionals at all levels, which are innovative, which are creative, and future ready. Uh, we all at CBSC are very much committed to integrate skill education into the mainstream schooling and with the mandate of NEP 2020. The introduction of various skill courses, including automotive. The main aim is to impart that kind of knowledge, that kind of practical knowledge, that kind of industry exposure and employability skills from early stage. And the initiatives like NAO are the key builders for that. Key points for that. So the NAO is that kind of excellent initiative that we have witnessed and encourages students to explore automotive technologies and innovative thinking also. One of the major initiative of board I would like to mention here that which is a skill expo where students from different schools do showcase their initiatives, do showcase their projects, and that kind of connectivity is to be done with our all kind of projects so that there can be excellent platforms for our students. I would like to sincerely thank ASDC, NSDC, and all collaborating organizations for their continued partnership with CBSC, majorly in promoting skill education in the country and creating meaningful learning opportunities for our students. Together, let us continue to empower our youth with the knowledge, skills, and confidence to build an Atmanirbhar Bharat and our journey to Viksit Bharat 2047. Thank you. Jai Hind.
Thank you very much, sir, for those grateful, insightful words and for encouraging our students to explore new areas of learning and career opportunities. So let's now start with the first session, a journey through the history of automobile design. We will now begin with the first expert session. The automobile has come a long way, from the earliest vehicles to the highly advanced technology-driven automobiles that we see today. The evolution of automobile design is a fascinating story of innovation, creativity, technology, and changing human aspirations. To take our students on a short journey through the history and evolution of automobile design and to bring us the story of automobile design in India, we are delighted to have Shri Gautam Sen, celebrated automotive journalist, author, and historian. Sir, we look forward to hearing your stories and insights and discovering how automobile design has evolved over the years and shaped the automotive world we know today. Over to you, sir.
Good afternoon, everybody. And I'm very happy to be able to present to you a little history of the automobile, which is a fairly long history, surprisingly enough, not just a 100-year-old history. In fact, the very first automobile was, when you say automobile, is a vehicle which is self-driven, which is not powered by or pulled by a horse or an elephant or by people, but a vehicle that could, let's say, power itself, in fact. In fact, the first one was a steam-driven vehicle, which is more than 250 years old. So maybe I'll take this opportunity to sort of share my screen, if that's possible, and take you through a few images to give you an idea of what the history of the automobile has been in terms of shape, design, and technology. So the first one is this, which I'd like to share. I think the share option should be yes. I've asked for the permission to share, and yeah. So that's if you. I don't know if you can all see. There is
Yeah.
photograph of a strange device, a vehicle of the
Yes.
first, in fact, automobile, which was from 1769. This was designed. In fact, it's not very far from where I'm sitting. I live in Paris, so this is barely a few kilometers from where I am, in the Arts and Métiers Museum, which has the oldest vehicle ever designed and made, which was done in 1769, which was essentially like a truck. It was meant essentially to pull heavy items, specifically artillery guns, and not was not, let's say, a vehicle in a normal sense. The sec But it took another 100 years before the vehicle, in fact, the first of the real vehicles started being made. This was a steam-driven vehicle from 1878. And if you see, it looks like a horse carriage. It was like a carriage, in fact, without the horses. That was how it was originally conceived, the automobile. Then by 1890, you had the first shape that had an engine at the front and people sitting behind it. Of course, this is the very first vehicles is from around 1890. It's a Panhard de Lavoisier, French vehicle. And these were made in fairly big numbers for the period. Into hundreds of these were made, in fact. And at that point of time, this is the start of the automobile. At the start of the automobile, only engineers were involved. There were no designers, there were no stylists involved. They were first essentially engineering the vehicle, making the vehicle. And part of that also happened to be the quest for speed. So what you see today is what you see here on the screen is one of the first vehicles that made an attempt and did beat the land speed record, the fastest uh, object on Earth. This was a vehicle called the Jamais Contente, done by a Belgian.
Gautam, you have not changed the slide.
Sorry?
Gautam, you have not changed the slide.
It has changed, but I guess it's not showing. So let me come off and come on again, I think.
Yeah, Gautam, just try that once more.
Yeah. Can you see the slide now?
Yes.
A black and white? Yeah?
Yeah.
Yes. So this is basically a vehicle that was designed and made in 1899 to break the land speed record, which that time this vehicle went 100 kilometers per hour at that point of time. And as you can see, it is shaped like what they call a torpedo. And in fact, the French term for torpedo was used for cars for a long time. And this car was electric. Interestingly, was electric. I'm moving to the next slide. Tell me, can you see this slide?
Yeah.
Which is
Yes.
the drawing. Yes. So this slide is where an attempt was made to, let's say, first time, let's say, design a vehicle, design a shape, to put a shape to a vehicle. This was an Alfa Romeo, an Italian car, and a certain count who wanted to make his car the fastest in the world decided to put a body which was like a torpedo pointed at the rear. And this car was designed in 1914. It was made in 1914. Can you see the next slide, which is a blue colored slide?
Yeah.
And so that vehicle was a vehicle that came up in 1923 by a gentleman called, it was called the Tropfenwagen. And it was designed by a gentleman called Edmund Rumpler, who was Austrian, but working in Germany, where he decided to design a vehicle which is very aerodynamic. It was a vehicle that was extremely aerodynamic, had a strange shape. Because of the strange shape at that point of time, it did not succeed. In fact, it was a bit of a failure in terms of commercially, but it did prove the fact that you could design vehicles which were efficient and aerodynamic. And that's where the role, let's say, of the designer started coming in after this. And in that case, I'd like to show you, this is a black and white photograph with three cars that you can see, actually four cars.
Yeah. Yes.
Can you see them?
Yeah.
Black and white. So these are vehicles which are essentially was designed by an Austrian aerodynamicist named Paul Jarre, Jarre as Jaray, Jarre. He was working during the First World War. He worked for a company called Zeppelin, which were designing airships for essentially for bombing, for war purposes. And then, of course, after the end of the First World War, when Germany was not allowed to build any more of these airships or airplanes, Yare decided to go into designing automobiles. And he designed these very aerodynamic automobiles, which were very strange looking, far from being good looking, and he wanted to promote these ideas, and in fact was not very successful in promoting these designs because they were strange looking. At the same time, Ettore Bugatti, you must have heard of Ettore Bugatti. Bugatti made some fantastic cars. The most expensive car today in the world, one of the most expensive, is a Bugatti. So Mr. Bugatti also decided to take inspiration from aviation and design a racing car, which was like this, which was a Type 32, and it was called the Tank because it reminded people of the tanks which had come out during the First World War. Again, Ettore Bugatti was not an engineer, interesting enough, and in a sense was one of the first, let's say, stylists, if you call it that, or designer, because he worked on it. He did work on the engineering aspects of the car despite not being an engineer, and was very successful. This particular car was a failure because the design, he got it wrong in the sense that the wing worked the other way around, and the car, instead of staying on the road, was tending to fly off, in fact, let's say take off, and meet with and it met with the first races it went. Out of the four cars, three of them went off the road, had accidents, only one finished, and didn't do very well, was not very successful. But the idea of shaping the body of the car started becoming, kind of came into vogue in the 1920s. But in the 1930s and 1934, Chrysler, seeing the trend for aerodynamics, decided to design a car which was aerodynamically efficient, the Chrysler Airflow. And in fact, when it came out, it was seen as one of the most advanced cars of the era, and was in fact likened to the same idea of using aerodynamics for locomotives. And this car, the Chrysler Airflow, was launched and was considered straight away. It was, in fact, it was on the cover of Time magazine, and people thought that this was the future. Unfortunately, the clientele, the customers, did not take to such an advanced design at that period of time, and the car did not do well, and was commercially a failure. Yet, it inspired Peugeot in France to come up with their own aerodynamic design on a car which was basically simpler, and was in fact more successful than Chrysler was when they tried to match aerodynamics with aesthetics. And that is, so you see the advent of, let's say, the stylist, the designer started coming into practice. Though this car, the work was that of Jean Andre, who was an aerodynamicist also. And in fact, this car that you see that he designed after that was aerodynamically an extremely efficient car. I hope you're seeing this black car image that you see, which is basically was a very aerodynamic car that came out in 1937, before the Second World War. But again, was quite expensive, so he not very many numbers were sold. In fact, only one of these cars today survives, the one that you see, but was extremely, let's say, aerodynamically efficient, was also aesthetically very interesting, was very advanced for its time. And that's where the idea that you needed to have designers involved in designing cars became more and more important. The American manufacturers saw that there was commercial sense in having designers come out with new designs every year. So after the end of the Second World War, into the later years, into the years of the 50s and 60s, I'm taking you straight to 1962, when this car was came up as a concept from General Motors. So manufacturers, especially the American manufacturers, including General Motors and Ford and Chrysler, they realized that design was something that they could sell, that actually styling was very important. And every year, in fact, they kept making different designs and different styles and different concepts. And those cars kept getting, as they kept coming out with different shapes and different evolutions, they sold more and more numbers. And in fact, they also started then involving you could, what at the beginning, in fact, there were more, I would say, stylists. And in fact, maybe Jean-Paul will explain to you the difference between styling and design. But styling was where the basically the engineering aspects of the car were frozen. All the stylists did was to shape different aspects of the car, the overall form, the front end, the rear end, details were done by stylists. The role of the designer started coming in the late 50s and early 60s, where they were in fact not only deciding on what would be the engineering aspects, actually they were actually creating the form first, the engineering followed. And that was a big change in the late 50s going into the early 60s, where the designers would actually define what would be the shape of an automobile. And then the engineers had to fit the engine and the other technical and the mechanical elements within that shape. Of course, to be a designer of that kind, you needed to understand what engineering was all about, what was going to go into a vehicle. And that's where the switch from styling to design became very important. And I am using this particular car, which was Chevrolet Corvair concept, as a point where you could see the change, where the designers came in and said, okay, we don't want the engine to be this car. The original engine was actually behind the rear wheels. And they said, no, we want the engine to be placed ahead of the rear wheels because we want to make a car that is more balanced dynamically and more balanced in terms of design too. And so that's where the designers started playing a role. And a very good example of that was this particular car, the Lamborghini Miura, which in the opinion of many people in the world is probably one of the most beautiful cars ever made in the 20th century, where the engineers and the designers worked together, where the designer was as much involved with making some changes to the engineering aspects of the car, and in the process, deciding what the shape would be, which would be efficient both in terms of aerodynamics, both as well as in terms of aesthetics, where you manage to match engineering, let's say, objectives with that of the aesthetic objectives as with that of the aerodynamic objectives. And so this is an example of that. There are several other examples from the 60s. We don't have time for all of them, but I wanted to show this to you. And the fact that with cars of this kind in the 60s, we started getting to know more and more about the designers involved with designing these cars. The designer of this car was a gentleman called Marcello Gandini, who is generally acknowledged to be one of the great designers of the 20th century. There's another person called Giugiaro, who's probably designed more cars than anybody else in the history of the automobile. And so you started having designers who started playing a role, who came more and more to the forefront. In fact, I would say that started with a stylist like Harley Earl, an American stylist before that. But into the 60s and 70s, we had more and more, let's say, star designers who were becoming more famous as they were leading automotive design in many ways. An example of that, of leading automotive design, is this Alfa Romeo Carabo, which changed the idea of designs where cars became more like a wedge, which were pointed low and very, very sharp at the front end and more stubby at the rear. And in the process, aerodynamically, it was very efficient. And I think I will leave you with the last image of one of these cars, which is probably the ultimate design. But this is more than 50 years ago. Since then, design has evolved quite a bit, but that probably the 70s was, in a sense, the peak of automotive design. The golden era of automotive design was 60s, 70s, at the most 80s, and in fact, 60s and 70s. And after that, what has happened is more gradual evolutions, probably not that many revolutions that happened in the 60s and 70s. So I'll leave you with this, but basically to give you an idea of the fact that the role of the designer at the beginning of the automobile didn't exist. It was essentially engineers who led, let's say, whatever innovations happened. And then after the Second World War, the stylists came into play. The stylists had a lot of role to play in the 50s, and the designers started coming into, let's say, having a greater role by the 60s. And since then, designers have left automobile design. I think I'll end with that.
Thank you, sir, for this enlightening session. I'm sure our students will look now at the automobiles around them with a different perspective and appreciate the history, evolution, and thought that goes behind their design, especially the journey of automobile design in India. We now have traveled through the history and evolution of automobile design, and we have also seen how automobile design has developed in India. We now move from understanding where automobile design has come from to understanding how an automobile is actually designed. To introduce our students to the basics and fundamentals of automobile design, we are delighted to have with us Mr. John Paul, celebrated industrial designer and former designer associated with BMW and Zagato. So we are extremely pleased to have you with us today and look forward to gaining an insight into the creative and exciting world of automobile design. Thank you, sir. Over to you, sir.
Hello, good afternoon. Thank you for inviting me. So today I'm supposed to talk about the fundamentals of automobile design. So I didn't, in this presentation, I didn't want to get too technical. I just wanted to talk a little bit more about the journey of the designer within the overall structure of the car industry. What exactly does the trade look like? So let me just start just share my screen. Okay, do you see it?
Yes, we do.
Yes, sir, it's visible.
Yeah.
Yes.
Okay, so what are the automobile design fundamentals, right? So the idea is to go from passion and singularity to form, teamwork, and reality. So the thing is that the fundamental of design really at the basis level is really the key is to take an idea, an emotion, or an intention and slowly transform it into something that's real. So do you see the second slide?
Yes.
Okay. So the idea is that typically in OEMs, what happens is that there's often, now today Gautam was talking about the relationship between designers and engineering, and now more and more we have marketing. So a lot of the times, marketing and engineering come up with after a thorough study of a given market, they come up with a package and brief designers on the upcoming project, right? So it's something that doesn't exist, and the designer is supposed to take that information in, and then that's food for thought in what he's going to do. So typically, we are given packages which are technical packages, but we definitely have hard points. But the thing is that the designer is supposed to basically takes that information and starts to think about it. So here at this stage, after the meeting, that basically gives him enough data and information for him to think about what he's going to do. So the next step of the design journey is basically he's going to start sketching. So the sketch phase is starts with very rough sketches. Definitely either pencil sketches, very simple, and more the sketches become a little bit more sophisticated. But today with modern tools, we use a lot of software for sketching, and we also use 3D softwares. And so the idea is to kind of go back and forth between your 3D and your flat work with the package in mind. So the thing is that so it's not just about it doesn't start from zero. It starts with basically technical data. So it's not it shouldn't be seen as something which is limiting in terms for the designer's creativity, but more something that it's basically a starting point. And depending on the project, it's more or less tolerated that actually some technical data which is given to the designer can be altered if the design calls for it. So typically, once the form has been sufficiently sophisticated and developed, there's a presentation with a technical team where they review basically the form in relationship to the package, the technical data that was given to the designer. And then typically there's further form development, and that's basically using CAD. So designers, especially young designers, understand the softwares very, very well. But sometimes they also work with professionals who are really dedicated to the software technology, and also who are very good at understanding production requirements. So after generally the 3D work, oftentimes, I mean, here I present it's further form development. So oftentimes, I mean, small clay models or scale clay models can be milled, or now we also use 3D printing to see how that shape looks in the real world. Because when you work with a computer, it's true, you're in 3D and you have a very good sense of form, but it's still not a real object. So generally, we're allocated time and resources to work on scale models. So the point of this is to validate in a way the form. Sometimes it's transitions in terms of surfacing, feasibility, those types of things. And when the design is mature enough, then there's a design presentation. So the thing is that designers is it's teamwork, but there's also internal competition with other designers who will work on the same project and present different concepts. So this is always a very exciting moment for designers, because in that sense, he's able to see where he stands in relationship to the project, the idea, to see if his ideas are or how good they are in comparison to what other designers have done. So oftentimes, this is a very exciting moment, and in many instances, the competition between designers is a positive emulation, and oftentimes your fiercest competitors are always or often your good friends. So I mean, yeah, I think this is one of the most exciting moments in the design process and the design journey. So the next step is when a design is selected, a clay model is milled generally, and then refined with clay modelers. So in this instance, you realize that the design journey is really, so there's a singularity that OEMs are looking for. It's really the designer's creativity, but it always comes in the context of teamwork. You know the people that you work with, and a good designer really understands how indispensable that is. So it's always getting the right tension between keeping the singularity of an idea, but then understanding that the alterations and the different expertises that you need for your original idea to become reality. So the next slide is basically, so it's refinement. So it's prototype development. So this is really when the in full size, when the design really becomes reality in that sense. So generally they're one-offs. Sometimes they're working prototypes, sometimes not. But the thing is that those are really look like the finished product, or at least as close as possible. So then what happens is, so when the model is finished, there's a final pre-production review, which is generally in front of the board. With generally you present either with a chief designer or a chief engineer, and to validate everything in front of the board, to say that the design works perfectly well with the engineering package, and that everything is functional and set to go. So this is always always a little bit sometimes intimidating to present in front of the board, but the thing is, when you're happy with your design, it's also a very proud moment for designers. So then the next phase is basically when the prototype is validated. The OEMs will build a series of prototypes to start to run tests. So generally they're camouflaged because the OEMs generally want control over the reveal of their designs. So we can see a lot of these cars going around in the Nürburgring with camouflage. It's basically for the final settings, and basically it's a stress test for engineering. So it's definitely more of an engineering exercise than a design exercise. But sometimes the designers are involved, and sometimes they're involved in the camouflage itself. So the next slide, that's the grand reveal. So generally, at a set date, OEMs decide to reveal either the pre-production version or the full production version in an event. Nowadays in Europe, the Villa d'Este in Italy is really a major event, especially when it comes down to presenting high-end cars. So I would say this is probably the proudest moment or one of the proudest moment of a designer, because then it's really his design becoming a reality. And there's always that thought of, of remembering the first idea, the first sketches, the first lines, to seeing a car in the real world, and to see how the idea is received. More and more designers are asked to make those presentations. Sometimes it's the head of marketing, but many a times it's the designer, either of the interior or the exterior, or sometimes both, make the presentation. And then next slide is basically, it's the early production phase. So journalists are allowed to test the vehicle. to get first impressions and so start to write articles. So it's really a communication strategy that that OEMs like to use, just to get press and impressions and to get the idea out there. So it's a kind of a pre-sale idea, and then finally, if the press, journalists, and car enthusiasts use pre-production prototypes. So this is actually when the final production starts, because there's always a little bit of fine tuning, especially when it comes down to building, manufacturing sports cars. So then, before the cars are shipped to the customers, especially with high-end sports cars, there's always a last-minute fine-tuning of the vehicle before the keys are handed over to the future owners. And then finally, the last slide is, well, when you see your design on the road, I think that's also a very proud moment. I mean, there's always, again, the thought of the entire journey to this point. So this is really the ultimate satisfaction for a young designer. So in a nutshell, so how is a car created? So first it's research and ideas, then it's form development using sketches, 3D, clay modeling. There's a kind of back and forth for the with engineering and sometimes other designers. I mean, you'd be surprised sometimes of how your colleague, how your colleagues can actually sometimes actually help you when you're in a pickle or when you're stuck. Then there's the prototyping phase. Then there's the testing, and then there's the final production. Okay, thank you very much.
Thank you, sir, for this wonderful and insightful session. I am sure our students have enjoyed getting a glimpse into the creative world of automobile design and have gained a better understanding of the fundamentals and thought process that go behind designing the automobile. As we come to the final expert session, it is now time to look towards the future of the automobile design. The automobile industry is undergoing a significant transformation from electric and connected vehicles to advanced safety technologies, sustainability, and new mobility solutions. Design is becoming more important than ever before. But what is growing role of design in the Indian automotive industry? And for young students who are passionate about automobiles and creativity, why could automobile design be an exciting career choice? To help us understand the increasing importance of automobile design in the Indian automobile industry and the exciting career opportunities that this field presents, we are delighted to invite Shri Ivy Rao, Distinguished Fellow of TERI and former Managing Executive Officer R&D at Maruti Suzuki India Limited. Sir, we are honored to have you with us today. We look forward to hearing your insights on the future of automobile design in India and understanding why this is such a terrific career choice for the young generation. Over to you, sir.
Thank you. Good afternoon, everyone. Let me share my screen. Are you able to see the screen?
No, sir, not as of now.
Just one second. Hmm. You are able to see it now?
Yes, sir.
Yeah. Good afternoon. Gautam and JP have talked about uh, the evolution of automobile design and also various stages of how basic design of automobiles is done, ending with the final prototype and testing, etc., before it gets delivered to the customer. Uh, I would like to talk about the basic difference between design and engineering and importance of both in developing or creating a product. Uh, I want you to look around in your room for just 3 seconds. Look at your bag, your water bottle, lights above you, and the chair here you are sitting on. Every single one of these things has a secret story behind it. A story that did not start in a factory, it did not start with a machine. It started with someone somewhere just imagining. Today's little title says it all. Every great engineering story begins with design. We are going on a journey. Imagine, design, engineer, build, and by the end of this session, we will never look at a bicycle, phone, or even your school bag the same way again. Actually, I had prepared this PPT imagining that it would be an interactive session. And I came to know that it's not possible to have interactive session very late. So I could not really modify my uh, PPT. I have given three sets of items here: house or brake, car or engine, and mobile or circuitry. To check what do you think just come first. Uh, the actual answer is that none of them have come first. None of, not the house, not the brake, nor the car, nor the engine. What actually came first was something you can't even hold in your hand. An idea. Somebody at some point in history sat down and thought, would not it be amazing if we had a machine that could carry us faster than we could run? That thought, not the metal, nor the wires, is where the car began. So remember, because we all come back to it again and again today, the idea always comes first. Let's talk what is design. If the idea comes first, what do we do actually with the idea? That is where design steps in. Design is not just about making things look pretty, although that is part of it. Design is really about three things: solving a problem, imagining something useful, and thinking about the people who are going to use it. This is same with your water bottle. Someone thought people need to carry water around all day without it leaking or being too heavy. That thinking before a single bottle was made is design. Even your bicycle, someone imagined a kid your age riding it comfortably, safely, and looking cool while doing it. That is design at work. So here is the big idea for this slide. Design always starts in your imagination before anything is ever built. It is the blueprint of a dream. Now, here is where it gets exciting. Imagine you have designed the most beautiful bicycle in the world, attractive colors, a comfortable seat, a cool design. But what if it breaks the moment you sit on it? Engineering means taking that beautiful design and making it actually work in the real world. It is a difference between a dream and the product you can trust with your life. Literally, when we talk about cars and bridges, engineers ask four big questions about everything they build. Is it strong? Is it safe? Is it reliable? Meaning, will it keep working tomorrow and the day after? And is it affordable so people can actually buy it? So remember, design dreams it up, engineering makes sure it does not fall apart. Now let us connect all dots now with one simple journey. A journey that every product you have ever touched has traveled through. It starts with a problem, something that is annoying, missing, or just not good enough. That problem sparks an idea. The idea gets shaped into a design. The design is tested and strengthened through engineering. Then it is made in large numbers through manufacturing. And finally, it reaches you, the customer, the user. Let's look at some examples. Let's look at bicycle because almost everyone here has ridden it. When design team sits down, they ask, can anyone ride it no matter of their height? Is the seat comfortable for long rides? Does it actually look good? Because let's be honest, nobody wants an ugly bike. But then the engineering team takes over and asks a completely different set of questions. Will the frame break if I hit a bump? Can it carry my school bag and me without bending? And most importantly, will the brakes actually stop me before I crash into a wall? This is an example of mobile phone. The design side cares about it being beautiful, easy to use it with just a tap, and having a camera that makes great photos for your social media or family albums. But underneath that shiny screen, engineers are fighting some serious battles, making sure the battery lasts a full day, the processor is fast enough to run your games without lag, the phone does not overheat in your pocket, and is strong enough to survive a small drop. Now let's look at cars. This is where you really start to see the scale of teamwork. The design team dreams up, as explained by JP, dreams up something stylish, comfortable, safe looking, and fast. They sketch curves, choose colors, imagine the interior. But to actually deliver the dream, the engineering team has to build the new engine or motor or a battery design brakes and suspension that work on every road, and run actual crash tests to protect people inside. Thousands of engineers working together just to make one designer's dream come true. That is scale of engineering. Now let's talk about water bottles slightly more. When you look at water bottle, can you imagine why the belt is not a rope but is a flat strip? I want you to really feel right now every single one of those ideas that you can imagine, valid design idea. Companies pay designers a lot of money to come up with exactly kinds of improvements to improve a product performance or appearance, etc. So you have designed your dream water bottle. Now comes the harder question. How does someone actually make that real? Exact engineers think about materials. What should the bottle be made of to keep things cold? Testing, does it actually stay cold for 6 hours or does it fail after two? Mechanisms, how does the cap open and close without leaking? And manufacturing, can you make a million of these at a low enough cost? The new ideas and with their engineering equals a real product sitting on a shelf in a shop. That equation, idea plus engineering, is honestly the whole secret of innovation. Now, here is something very exciting. This entire imagine, design, engineer, build world needs real people to run it. And that means real careers, possibly for some of you sitting right here. There are designers who imagine and sketch, mechanical engineers who build moving parts, electronics engineers who handle circuits and chips, software engineers who write the code that runs everything, AI engineers who are teaching computers to think, automobile engineers building the cars of tomorrow, architects designing buildings and cities, and industrial designers shaping the everyday objects we touch. None of these people work alone. They all work together like a giant team to build the future we are going to live in. Let's conclude everything together. If you remember nothing else from today, remember these four lines. Ideas start everything, nothing gets built before it is first imagined. Design imagines, it dreams up something useful, beautiful, and made for people. Engineering makes it real, it takes the dream and makes sure it actually works safely every single time. And every innovation, every single thing that has ever changed the world began with curiosity. Is someone asking, what if? So, as we finish today, I want to leave you with three lines. Say them, dream big, don't Shrink your ideas just because they sound too big right now. Every invention sounded impossible once. Design fearlessly. Don't be afraid that your idea is not good enough. Even a water bottle idea could become a real product someday. Engineer the future, because the truth is the next big invention, the next big idea that changes how millions of people live could absolutely be designed and engineered by someone sitting right here in this room. Design imagines the future and engineering builds it. Design comes first and engineering follows. Design defines what needs to be created. Engineering determines how to make it work. Engineering exists to meet design requirements defined at the beginning of the process. Innovation happens only when create, creative things, that is design, and technical excellence, that is engineering, work together. And now there is a lot of importance being given in the industry, especially auto industry, for basic design of the vehicle, because unlike in the past where performance of the vehicles used to be uh, deciding criteria for a purchase of a vehicle, now most of the important requirements are either mandatory and are necessarily required because of the competition. All manufacturers now working very aggressively design the vehicles for differentiation. And so design is going to be one of the key important aspects of automobile. So there is a very good scope for design as a profession. Thank you.
Thank you very much for those enlightening and valuable insights, sir. I'm sure our students have gained a much deeper understanding of how automobile design goes beyond aesthetics and plays an important role in innovation, functionality, technology, and future mobility. We now have reached the interactive segment of today's session. Since this is a YouTube live, we did receive some questions while the session was on. Students who have questions had posted them on the YouTube in the YouTube live chat box. We would like to share a few of the questions with the speakers now. So one of the questions that we received was, how do electric vehicles work?
Gautam, you are responding?
I think, Ivy, it's your question, in fact.
Okay.
Let's put it that way.
Basically, uh, unlike a vehicle driven by engine, IC engine, in case of electric vehicles, there is a motor which draws current from the battery storage system, what is there on board, and the motor drives the vehicle. And there are a lot of controllers to control or manage the battery and also the motor and the overall vehicle performance. So the battery size depends upon the size of the motor being driven for the vehicle based on the vehicle requirements, and also the range what is expected from charge to charge. Yeah.
the students had also asked the questions about the seating capacity, the price, and how the cars were manufactured at the time, at the timeline that was shared by Sir. And one of the major questions that we have received was about robots and what role do they play in manufacturing these vehicles. So if anybody from you would like to take up this question, sir.
Shall I take
I
this?
think about seating capacity, maybe Jean-Paul could be the best,
Yeah.
and for robots, maybe again Ivy would be better.
Yeah. Okay. JP, go on.
So the question is about seating capacity, but
Yes.
but what in relation to seating capacity?
So the cars that you had displayed in your presentation,
Okay.
that one.
Yeah, so that was a mid-engine sports car. So typically it's a two-seater. Sometimes you find rear engine. The most notorious rear engine which is a 2+2, which is basically two adults and two baby seats, or for younger children would be the Porsche 911, because it has the engine further back, but the one that I displayed is clearly a mid-engine, so the engine in front of the rear wheels, so it's only a seating capacity of two.
So so the next question, Gautam sir could take.
In India, use of robots has increased over last 2 decades. And when I started working in Maruti, there were two pairs of robots which were used on the weld shop, where the holding of the gun and accessing the actual location where the spots have to be made were very difficult for human beings to do. Those were the places identified for deploying robots. But since then, the number of robots being used in the auto industry has gone very high, especially in weld shop and paint shop for finish painting, where the the holding of guns and this spray guns in case of paint shop can accurately be controlled to get the best position. And also in case of weld shop, the holding gun and accessing various locations for spot welding becomes extremely difficult. So robots would be doing consistently uh, the required job. And the advantage of a robo is once it is taught what is to be done, it repeats without any flaw, without any deviation continuously. So more and more robots are being deployed in various mass manufacturing stations, and also where precision and repeatability is extremely important. Those are the applications.
So one of the questions was regarding what happens to the EV batteries after they are no more functional.
Uh, See, there when the battery is initially uh, used on a vehicle, the battery life goes on till its useful life comes down to 40%. That's when it is said that the battery is not suitable for automobile application. And then it goes for the secondary use, which is a stationary application of the batteries for mostly storage purposes. And once that life is also over, then the battery, what is being worked on as a regulatory requirement is to take it for recycling, where the battery materials, the raw materials which are used for making the cells will be extracted from the dismantled battery cells. These processes are being refined. There are a couple of startups who claim that they have already achieved good efficiency in claiming lithium, cobalt, etc. from these used cells.
So this question is, why is the design model made out of clay? Any particular reason for using this clay? Why not some other material?
JP?
Yeah, so clay is used because it's a very flexible material. So the thing is that it's still when a car is being modeled, it's still within its form development phase. So you can still alter and change things in clay, which is and it's very easy to do. Whereas if you use a harder material, then these things become more difficult. I mean, typically, the Italians used for a very long time plaster. So, so plaster is also flexible, but it's less flexible than clay. So that's why clay has been overall globally adopted as the key material for form development. So the tricky thing about clay is that actually when you have a clay model, it oftentimes it's actually heavier than the actual full prototype working prototype, because clay is actually quite heavy. That's the caveat, but it's very flexible. It's non-toxic, and it can be recycled. So that's why clay is adopted by most of OEMs around the world.
I think we have covered most of the questions. So thank you all the students for your interesting questions, and I hope this session did uh, accelerate your curiosity about the automobile sector. So, as we have come to the end of today's session, I would like to express my sincere gratitude to all the distinguished speakers for taking the time to interact with the participants of the National Automobile Olympiad 2026. A special thank to Shri Satish Pahal, Joint Director, Department of Skill Education from CBSC, for joining us and sharing his valuable thoughts with our students. I would also like to thank Shri Ivy Rao, Shri Gautam Sen, and Shri Jen Paul for making this session truly enriching and inspiring. And to all our young participants, I hope today's session has encouraged you to look at automobiles not just as vehicles, but as a fascinating combination of engineering, technology, creativity, design, history, and human imagination. The world of mobility is changing rapidly, and the future will need young minds who are curious, creative, and willing to learn. I encourage all of you to continue exploring, asking questions, and nurturing your interest. Perhaps some of you are attending this session today will go on to become the automobile designers, engineers, innovators, and mobility leaders of tomorrow. Thank you once again for everyone for being a part of this special session. With that, we conclude today's session on Introduction to Automobile Design. Thank you and have a wonderful day ahead. Thank you, everyone.
Thank you.
Thank you.
Thank you very much. Thank you.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you very much. Bye.
Thank you.
Bye-bye.
Thanks, Gautam.